Among the billions of stars adorning the sky and distant galaxies lost in the eternity of the universe, the solar system has always attracted the curiosity and admiration of human beings. For centuries, observers, scientists and travelers have endeavored to solve the secrets of planets, satellites and other celestial bodies in this magical system. Although the solar system seems to be only a small point in the face of the size of the universe, it draws attention with its eye-catching wealth. While our main star is in the heart of the Sun, the system of the system, various celestial bodies, such as planets, satellites, asteroids and comets, form the exciting structure of this system. The first planet revolving around the Sun is Mercury. Mercury is one of the inner planets closest to the Sun and has a rocky surface. Then, the temperature and atmosphere comes to the forefront. Then, we encounter the world, the only planet where life is possible. The world is a planet like a paradise with water, atmosphere and life. A little further away from the Earth is Mars with its red lands and mysterious history. On the surface of Mars, old volcanoes, canyons and glaciers, a great source of interest for humanity, have been discovered. Jupiter, the largest of the planets in the solar system, stands out as a huge gas planet. The large number of satellites in enormous dimensions that revolve around Jupiter make it quite impressive. Saturn is another gas planet that is famous for its rings. These striking rings attracted the attention of astronomers and aroused curiosity for many years. Uranus and Neptune are known as ice giants that attract attention with their cold and blue colors. These planets contain mysterious storms in their depths and fascinating atmospheric events. As we move towards the boundaries of the solar system, we reach the asteroid belt and comets. These small celestial bodies carry traces of the youth of the solar system and contain evidence of the collisions in the universe. Asteroids are rocky and metallic objects circulating in the gap between planets. The tailed stars are objects that are known for their flashy tails as they approach the Sun. The borders of the solar system are more distant areas such as Kuiper Belt and Oort cloud. The Kuiper Belt is a region beyond Neptune and has millions of small celestial bodies. Here, dwarf planets such as Pluto and trans-Neptune objects are discovered. The Oort cloud is located in the most extreme area of the solar system and is assumed to have billions of comets. The search for life in the solar system is also an important issue. In order to understand whether there is life outside the planets, scientists are investigating the traces of life in the satellites and asteroids of Mars and other planets. The fact that there is evidence of the existence of microorganisms suggests that humanity is not alone in the universe. Humanity has made great efforts to explore and understand the solar system. Many information and images have been obtained through space research, space stages and astronauts. Apollo missions were set foot on the Moon, the surface of the Red Planet was examined with Mars Discovery vehicles and the secrets of deep space were revealed thanks to the space telescopes. In the future, humanity aims to make more discovery in the solar system and perhaps to perform travels between planets. The process of formation of the solar system begins with the stage of gas and dust cloud. This stage is characterized by the presence of a huge cloud of gas and dust. These clouds are mostly composed of the residues of popcans or material particles formed as a result of the supernova explosions. Gas and dust clouds are found in low-density areas in space. These clouds include light elements such as hydrogen and helium, as well as the combination of other heavy elements. The size and mass of the clouds can be quite wide, sometimes they can be as much as thousands of sun mass. These clouds are usually formed by the combination of various factors. These include the residues of the popcans, the collisions between the stars, the supernova explosions and the collapse of molecular clouds. As a result of these events, gas and dust particles come together to form dense areas. Intense areas collapse by stuck with the effect of gravity. This collapse process is realized by bringing together gas and dust particles by gravity. Gradually collapsing clouds gain a more dense and hot structure. As the collapse process continues, the gas and dust cloud rotating movement also wins. This rotation movement protects the moment of the cloud during the collapse process. Thus, the interaction of collapse and rotation triggers the formation of a protoplanetary disk that rotates around the core. Protoplanetary disk is in the form of a disk that rotates around the core. This disk slowly comes together to form the planets and other celestial bodies of the substance around the nucleus. The gas and dust particles in the disk make orbit around the core. Protoplanetary gas and dust particles on the disk come together as a result of various physical and chemical interactions and initiate the formation of large objects. Small dust and gas particles combine to form asteroids, comets and other small objects. These small objects then join the planets of the planets, form the basic building blocks. It is an important stage of collapse and rotation in the process of formation of the solar system. This stage is that the gas and dust cloud collapsed under the effect of gravity and gains a more intense structure and at the same time gaining a rotational movement. The collapse process begins with the jamming of the gas and dust cloud together by gravity. The gas and dust particles in the cloud are drawn to each other with the effect of gravity and begin to intensify. This condensation allows gas and dust particles to come together to form larger and intense objects. As the collapse process progresses, the cloud becomes more stuck and triggers the formation of nuclei. The core is a region formed at the center of the condensation and has larger mass than other objects. The core is the most dense and hot region of the collapse and has a structure similar to the center of the Sun. At the same time, the rotational movement of the cloud in the gas and dust cloud phase gains momentum. This rotating movement allows the protection of the moment of the substance in the cloud. That is, the cloud maintains the rotation movement as it collapses and rotates around the axis of rotation and creates a disk shape. This rotation movement constitutes a structure called protoplanetary disk. Protoplanetary disk is in the form of a disk that rotates around the core. The gas and dust particles in the disk make orbit around the core. The rotation movement prevents the flow of the substance in the protoplanetary disk towards the nucleus. This rotation movement, which prevents the substance from falling into the nucleus, provides opportunities for more accumulation and growth. Gas and dust particles turn around the seed and contribute to the formation of larger objects. The collapse and rotation phase is an important stage in which the foundations of planets and other celestial bodies are laid in the process of formation of the solar system. In this stage, the core is formed by the collapse of the gas and dust cloud, while the rotation movement also provides the formation of protoplanetary disk. This stage triggers the formation of planets, asteroids and comets in later stages. Another important stage in the process of formation of the solar system is the protoplanetary disk stage. This stage is the stage in which the protoplanetary disk, a disk that rotates around the nucleus, is formed. Protoplanetary disk is a structure that prepares the ground for the formation of planets and other celestial bodies. With the formation of the core in the collapse and rotation phase, the gas and dust particles in the gas and dust cloud come together around the nucleus to form a protoplanetary disk. This disk consists of gas and dust that rotates in a plane structure around the nucleus. Protoplanetary disk, the substance around the core slowly comes together to form the formation of planets, asteroids and comets. The gas and dust particles in the disk make orbit with the effect of the gravity of the nucleus. The gas and dust particles on this disk are subjected to various physical and chemical interactions. For example, the loss of energy with the effect of friction of gas allows the dust particles to collide with each other. Small dust particles come together to form larger objects. The material in the protoplanetary disk rotates in different orbits around the nucleus. In the inner parts, the temperature and pressure are high and therefore usually gas. In the outer parts, the temperature and pressure decreases and there are more solid dust particles. In this process, the material in the disk grows over time and leads to the formation of planets. Small dust particles combine to form asteroids, comet stars and other small objects. Then, these small objects combine to form the basic building blocks of the planets. In the protoplanetary disk stage, the effect of gas on the disk is also important. The gas in the disk affects the flow of the material in the planetary formation process. In areas where the gas is located, dust particles can come together faster and the formation process of planets may accelerate. Protoplanetary disk stage is the stage in which the foundations of planets, asteroids and other celestial bodies are laid in the formation of the solar system. The next important stage in the process of formation of the solar system is the planetary formation phase. This stage is the stage in which the material in the protoplanetary disk is combined to start the formation of the planets. Protoplanetary gas and dust particles in the disk grow over time and become larger objects. Small dust particles come together to form asteroids, comets and other small objects. Then, these small objects combine to form the basic building blocks of the planets. Planetary formation begins with the formation of nuclei to come together by dust and gas particles. The seeds concentrate with the effect of gravity of the substance in the protoplanetary disk. This condensation process triggers the flow of the material around the nuclei towards the nuclei. The growth of the nuclei occurs by the combination of dust and gas particles and the collapse of the material around the nuclei under the influence of gravity. This process allows the material in the protoplanetary disk into large objects that initiate the formation of planets. In the process of planetary formation, the seeds gradually grow and become planetary candidates. This growth process occurs when the material in the protoplanetary disk is combined around the nuclei. The combination of dust and gas particles and the collapse of the material around the nuclei under the effect of gravity contributes to the growth of the nuclei. As a core grows, it interacts with the material around it and forms its atmosphere. The atmosphere occurs when the gas collected around the core and the rotation of the gas connected to the nucleus around the planet. The atmosphere may have different characteristics depending on the size, composition of the planet, composition and environmental conditions. In the process of planetary formation, the growth of the nuclei and the formation of the atmosphere continue to decrease. In the continuation of the planetary formation phase, some of the gas and dust particles in the protoplanetary disk are caught by the gravitational force of the planets, while some are dispersed outward or removed by star winds. This process results in a decrease in the material around the planets. With the growth of the seeds and the decrease in the material, the final form of the planets is shaped. Planets can have a solid inner region of nuclei. This inner region usually consists of metallic and stony materials. While the atmospheres of the planets also occur, the gas and dust particles in the protoplanetary disk contribute to the atmosphere. The atmosphere may have different components depending on the size, composition and environmental conditions of the planet. For example, gases such as hydrogen, helium, methane, ammonia and water vapor can be found on the planets. The process of planetary formation is determined by the interaction of different factors. These include the composition of the material in the protoplanetary disk, temperature, pressure, gravity and environmental conditions. These factors determine the properties and compositions of the planets. The planetary formation phase includes a long period of time, and the formation of each planet can occur at different speeds. While some planets occur quickly, others may require longer processes. In addition, collisions play an important role in this process. Planets grow and shape by colliding with other objects in the protoplanetary disk. The Sun is a large star in the center of the Solar System. The Sun is defined as a plasma ball consisting of approximately 4.6 billion years old and the majority of hydrogen gas. The Sun is a great gravity center that keeps them in place with the attraction of other planets and celestial bodies in the Solar System. The formation of the Sun begins with the collapse of a molecular cloud. This cloud may usually be stuck with a supernova boom or the effect of another celestial body. The collapse process allows the cloud to concentrate and jam with gravity due to gravity force. As the collapse process continues, a point of condensation occurs in the center of the molecular cloud. Here, the condensation point becomes more stuck and becomes an object called a protostar. Protostar is a structure that is not yet a star, but is in the process of becoming a star. When the protostar occurs, the gas and dust in it surrounds. The core begins to grow and attracts more materials with the effect of gravity. In this process, the temperature and pressure of the protostar increases. As the nucleus grows and the gravitational effect increases, the temperature and pressure required for the occurrence of nuclear fusion reactions occurs to the hydrogen gas in the inside. The nuclear fusion process allows hydrogen atoms to transform into helium atoms to reveal large amounts of energy. This energy is the source of the brightness and temperature of the Sun. When nuclear fusion reactions begin, the protostar becomes a star now. The gas and dust is cleaned around the cloud and the star continues to produce energy steadily while the hydrogen burns process. At this point, we can say that there is a star in the main sequence. The diameter of the Sun is approximately 1.4 million kilometers and is about 109 times the Earth. The Sun, which is also quite large in terms of mass, constitutes 99.86% of the total mass of the Solar System. The Sun has a dominant effect on other objects in the Solar System and holds them in its orbit. The Sun works as a huge nuclear fusion reactor. Its internal structure consists of three main sections: core, radiative region and convective region. The core is the hottest and dense area in the center of the Sun. Here, hydrogen atoms become helium atoms by nuclear fusion and large amounts of energy are released. The surface of the Sun consists of an observable outer layer called a photosphere. The photosphere is the place where the temperature of the Sun is approximately 5,500 Celsius. The Sun is a constant energy-producing star. This energy is obtained by the nuclear fusion process in the Sun's nucleus. The Sun releases a large amount of energy by converting approximately 600 million tons of hydrogen into helium every second. This energy allows other planets and celestial bodies in the Solar System to warm up and take light. The planets that revolve around the Sun move in their orbits, depending on the Sun. The planets in the Solar System are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. The Sun affects other celestial bodies as well as planets in the Solar System. For example, under the influence of gravity of the Sun, the asteroids in the asteroid belt and the orbits of objects in the Kuiper belt are determined. In addition to being a great source of energy, the Sun is the source of extraordinary sky events such as solar eclipse. The solar eclipse is a phenomenon in which the Moon passes between the Earth and the Sun and prevents part of the light of the Sun. Solar eclipses create great interest and excitement in the world. The life cycle of the Sun is a long process of about 10 billion years. The Sun is currently a star in the main system, main sequence. During this stage, it continues to convert hydrogen fuel into helium. However, when the hydrogen fuel is exhausted, the Sun will become a giant red giant star. In this phase, the Sun will expand even further, and as a result of nuclear reactions, it will spray its outer layers into space. This is the stage in which he will turn into a white dwarf star with the condensation of the helium in the core of the Sun. The role of the Sun is also of great importance in terms of the emergence and maintenance of life in the world. The Sun is the heat and light source of the Earth. Energy from the Sun allows plants to make photosynthesis and play an important role in the functioning of ecosystems. In addition, the light and heating of the Sun affect climate and weather events on Earth. The Sun has an important role in the start and continuation of life in the solar system. The Sun is heating the Earth and the formation of climatic conditions. In addition, sunlight provides the energy required for plants to make photosynthesis. Photosynthesis is the process of producing oxygen by absorbing carbon dioxide by taking energy from sunlight. This is a vital process for survival of all forms of life in the world. Changes in the magnetic field of the Sun cause dark areas known as sunspots. These stains occur as a result of condensation of magnetic field lines in areas close to the Sun surface. Since sunspots are colder and darker areas, they look less bright than the Sun surface. Strong changes in the Sun magnetic field may cause energy explosions called solar explosions. Solar explosions occur with the rapid reconstruction of the magnetic field and lead to large amounts of energy and particle spread. These explosions occur in the atmosphere of the Sun and may cause the sun wind to accelerate, spread the loaded particles into space, and the formation of magnetic storms if they reach the Earth. As a result of solar explosions and other magnetic events, loaded particles are thrown into space and interact with the magnetosphere of the Earth. As a result of this interaction, magnetic storms occur. Magnetic storms may affect the magnetic field of the Earth, causing displacement of magnetic poles and the emergence of natural events such as aurora borealis and aurora australis, magnetic poles. The magnetic field of the Sun affects the formation of the solar wind. The sun wind consists of particles that are constantly spreading from the Sun and shaped by the magnetic field of the Sun. The sun wind spreads to space at high speeds and interacts with the magnetosphere of the planets, causing the displacement of the magnetic poles, changing the shape of the magnetosphere and the formation of electric currents in the magnetosphere. With the influence of the solar wind, the magnetic field of the Earth creates a protective shield surrounding the planet in a region called magnetosphere. The magnetic field and effects of the Sun also affect space weather. Solar explosions and the sun wind can trigger magnetic storms with loaded particles and energy spreading towards Earth. Magnetic storms can damage electrical systems and satellite communication, increase radiation levels, and have effects on the health of astronauts. Therefore, space weather observation and estimated space missions and satellite operations are an important issue. The magnetic field of the Sun affects solar energy systems. Solar panels produce solar energy by converting sunlight into electrical energy. Changes in the Sun magnetic field can affect the direction and intensity of sunlight, which can affect solar energy production. Therefore, solar energy systems and solar panel efficiency are tried to be optimized by research that takes into account the magnetic activity of the Sun. The Sun produces energy with a process called thermonuclear fusion. This process takes place under intense temperature and pressure in the Sun. The core of the Sun is filled with large amounts of hydrogen gas. Hydrogen is the main fuel of the Sun and becomes helium gas by fusion reactions. The high temperature and pressure in the Sun combine the nuclei of hydrogen atoms to form helium atoms. In this process, a large amount of energy is released when the positively charged seeds of the hydrogen atoms come together to form a helium atom. Fusion reactions take place continuously in the Sun, and thus the Sun constantly produces energy. In fusion reactions, a decrease in the amount of mass occurs when creating the helium atom. According to Albert Einstein's famous equation, mass and energy can be converted to each other. Therefore, the loss of mass turns into energy and a large amount of energy is released from the Sun. The formed energy is carried into electromagnetic waves called radiation. The energy in the Sun spreads from the core region to the outer layers of the Sun. Hot plasma rises upwards with movements called convection. These movements allow energy to be transported to the external layers of the Sun. The solar system is an issue that has been observed and discovered by people for thousands of years. The Sun is the star located in the center of the solar system. People have observed the Sun for thousands of years. Phenomena such as the orbit of the Sun, solar eclipses and sunspots have been observed over time. The Moon is the Earth's satellite and the closest celestial system of the solar system. The phases and movements of the Moon have been observed for thousands of years. In order to obtain detailed information about the surface of the Moon, space missions to the Moon are of great importance. Since ancient times, 5 planets have been visible and naming with the naked eye. These planets were regularly observed and their movements were followed. With the development of telescopes in the following centuries, other planets were discovered. Galileo Galilei is a scientist who made important observations about the solar system in the 17th century. He observed the Sun and the Moon with his telescope at that time. Galileo discovered sunspots and mountains and craters on the surface of the Moon. In the 17th century, Johannes Kepler carried out important studies on the movements of the planets. Kepler discovered that the planets returned in elliptical orbits, scanned equal spaces at equal times, and that there was a relationship between the planets' distance from the Sun and their return. In the 20th century and after, many space missions were realized and the solar system was discovered in more detail. For example, with the Apollo program, people were sent to the Moon and more information about the Moon's surface was obtained. With spacecraft such as Mariner, Viking, Voyager and Cassini, tasks have been held to explore Mars, Jupiter, Saturn and other celestial bodies. The Kepler Space Telescope, launched by NASA in 2009, has been a major turning point for the discovery of planets outside the solar system. Kepler has found thousands of potential planetary candidates by detecting the planets called transit. These observations have shown that there are other planets outside the solar system, and some may have life-favorable conditions. Pluto was one of the solar system bodies, which has been regarded as the 9th planet for many years. However, in 2006, the International Association of Astronomy decided to cancel Pluto's planetary status and define it as dwarf planets. This decision led to controversy on the definition and classification of the planets of the solar system. Apart from the solar system, many celestial bodies and asteroids have been discovered. In the region, which is called Kuiper Belt, there are thousands of small objects, including Pluto. The most famous of these are Eris and Makemake. In addition, it is thought that there are millions of comets in a remote area called the Oort cloud. The Sun system discoveries have made us understand the physical characteristics of planets and satellites. In addition, some thunder such as Mars and Europa were found on the presence of water and the symptoms of potential life. This encourages the search for out-of-planetary life and research in the field of astrobiology. Observations and discoveries about the solar system helped people to understand the universe better and to investigate issues such as the formation, movements, structures and evolution of planets. With future space missions and developing technology, more discoveries are expected to make more discoveries in the solar system and the universe. The second part of the Solar System documentary will cover the planets and celestial bodies. For brand new documentaries and more scientific content, do not forget to subscribe to Pursuit of Science.